Hello and welcome to this new video. It's a pleasure for me to see you here and what we are talking about today. So, today we want to talk about supply chain security, about software supply chain security. What are the key points? What are the different mechanics? You can see here some open source projects from the Linux Foundation I want to highlight. And we want to have a look at vulnerabilities, malicious code package, and in the end, what you can do against all these attacks. If you're interested in this, stay here. By the way, my name is Sven Ruppert, I'm developer advocate for JFrog, and as you can see, mostly I'm out in the woods. And yeah, so if you are watching the first time one of my videos, then it's a big pleasure for me and a big welcome from my side. And if you want to have more videos like this about Java or DevSecOps topics, then have a look at my YouTube channel. You will see a bunch of them there. And if you like a video, give me a thumbs up, and it would be a pleasure for me to see you as my new subscriber. If you start subscribing my channel, you're missing no other video anymore. So, and now it's time to start. Okay, let's start talking a little bit about supply chain security. Supply chain security is a very broad topic, and software supply chain security is just a part of the supply chain security. What does it mean? Supply chain is everything that is used in terms of human power, about humans, machines, material, third-party components, processes, everything that is producing something, or it is some supply chain. So in everything that is disturbing it or compromising it is something against the supply chain security. And supply chain security is focusing exactly on this topic, how to make everything smooth so that you can work, or this process is running without any interruptions or disruptions. So software supply chain security is just a part that is focusing on how to create software. Okay, what changed over the years with the supply chain attacks? Longer time ago, it was more or less an individual or a group of hackers that tried to break into the supply chains, and it was more or less a financial-oriented aspect. So they wanted to get some money somehow. Okay, but over the last years, and especially right now, so we're in the beginning of 2022, we have a global political not so nice situation right now in the East, and then it could happen that if you're working directly or indirectly for a company that's working for government, or you're working inside the supply chain for a company that is not really is a target of a different government, let's say it like this, then it could be that you're not attacked by individuals or a hacker group, you're attacked by a government. And this is a complete different thing, because they have completely different resources, different possibilities, and even if you're a small, medium-sized company, if you're part of the supply chain, it could be that you are now attacked by governments instead of individual hackers. And this is a complete different beast. And what we can see is the big companies are improving their security day by day. They have a huge amount of resource in terms of manpower, money, infrastructure, and so on and so on. And this means that the pressure or the attacks, they are more and more not against the big companies, they are more and more against the small companies around these big companies. And this means that over the time this pressure will increase, and even if you have a small and medium-sized company with, let's say, 10 or 15 employees, you will get now the full amount of attacks on your part of the supply chain, because it is way cheaper to attack the small and medium business-sized companies and a few of them instead of attacking the big company. So it means the pressure is increasing step by step, and as much as the big companies are increasing their protection, it means the pressure against the small and medium business-sized companies will increase as well. And one of the biggest questions is, what is the key factor against all these attacks, or what is a fundamental thing you should have in mind? And whatever supply chain you have, the traceability is one of the key points against all these different attacks, or it's a fundamental thing to protect against compromised elements inside this. So traceability means that all parts, what you're doing, at what time, who's involved, what material is used, what is the output, where the output is going through, and so on and so on. If you are able to have this traceability about the whole supply chain, this is one of the key factors. But now we want to limit the scope from general software supply or general supply chain security to software supply chain security. And here we are focusing on from source code to binary. Okay, let's talk a little bit about the software supply chain security. It's a subset of the supply chain security. It's focusing just on software, and I have two open source projects from the Linux Foundation I really would like to highlight here. And one is the project Salsa and the other one is project Persia. Let's start with Salsa. Salsa is a project, is a documentation project, and it means that a bunch of different individuals or cybersecurity experts or security experts try to create documentation, first of all, to identify, so to give advice to you so that you know at what level you are with your security, what are the next steps, what you can do to increase your security, and a description of all the different common attacks against the software supply chain. So really, what are the attacks from source code up to the binaries in production? So part of Project Salsa are these levels. These levels are more or less so that you know where you are and what you can do, and what are the next steps to increase your security. And the first level is level 0, is just you have to document everything that is used inside your software development process. So it's a full documentation of everything so that you know what is going on, where is something involved, what components you are using, and so on and so on. So level 1 then is describing that you have to create an SBOM, software bills of material, so that you know this binary is depending on all the other components, all the other dependencies, so that you have the full dependency list of your created binaries. Don't worry, we will focus on this SBOM, what it is, how to create it, where you can get this stuff later on in this video. But so this is the level 1. The level 2 is that you start using a Git repository or a source code version server and CI/CD environment, as well as a repository for the binaries, and making sure that everything is automated as much as possible. Level 3 is introducing security audits, so it means that external parties are checking what is a security level you have, what you have done right and wrong, and what should you do better. And if you have done this, then the level 4 is describing the definition of hermetic, immutable, and reproducible builds. So it means that you know what is part of the build, that you reproduce it, and that you're creating binaries just once and then using them. So never recreate a binary. So all this is a very, very short overview of this project, but I have a video focusing just on this project SLSA on my YouTube channel. There I will explain all the mechanics, the details, and all different flavors, what you can see and get there. And have a look there on my YouTube channel and search for the video about Project Salsa. So the next part from this project Salsa is the documentation about most common attacks against software supply chain. And this means that we are focusing now from source code to binary, what could happen. And we have a few things. The first thing is, for example, no source code modification will be done without any review. If you have done this, what could be the next attack? The next attack could be that you are compromising the source code repository itself. It means that you're just sneaking in with bad commits or changing source code at this part. So you have to harm this source code repository. From the source code repository, it's now going to the build, the CI environment, and here again, it could be the build could be changed or it could be compromised in a way that's fetching the original sources but overlying with some other or additional sources, or that you are just compromising the build itself. A very prominent example of this is the SolarWinds hack, where with every build inside the CI environment, the binary was corrupted inside the CI environment. So hardening the CI environment is one thing. From the CI environment now it's pushed to a repository, and here what you can do is you can bypass the CI environment, say I'm the CI environment and pushing compromised binary into the repository, or you can attack the repository itself. But there are a few things. So we are talking about bad dependencies. So during the build, what you can try is to provide bad dependencies so that this is used during the build, and you can change or promote binaries from outside that will grab by the repository. Long story short, meaning we have several hotspots here, and the main hotspot is first of all the three components: the source code repository, CI/CD environment, as well as the Git or the binary repository. Here you just have to you have to harden this environment. This is a operational part, but for the software developers there are two things left: the own source code and what's going on with the source code, and then all this stuff with the binary, so all dependencies. And I think it's worth to have a look at exactly this part: source code and binaries. Okay, let's talk about the next project, and the project is called Persia. Persia is a project, it's an open source project from the Linux Foundation, and it was initially created by the company JFrog. And what we want to do, so in this project we want to focus from the binary will be built until the binary will be delivered. It could be as dependencies, it could be for production, but this is a part where project Persia is focusing on, and all the other parts are external not included in this project. So it means we are focusing here from now we are building a binary up to it will be delivered. How is Persia securing the software supply chain or this build process? So you want to take was again this build infrastructure, or this build threads, and here what Persia is doing is you're providing to this decentralized, it's a peer-to-peer network or a peer-to-peer package manager. What you're doing is you're sending the URL where the source code is and a commit, then different nodes will grab the source code, will build it locally, and then sharing the information about the binary itself. And then if all binaries are the same, then the build infrastructure is not compromised. So you can create different nodes of Persia, but you have no control about if your nodes are selected for building something. So it's really randomly selected in a way that it's very hard to really provide these nodes in a compromised way so that you can bring in compromised binaries with this platform. So now we have this binary inside this peer-to-peer network, and then it will be delivered to the distribution layer of Persia. By the way, this is a very short description of Persia, so if you want to have a more detailed, then check out my YouTube channel. I have there a video just about this project Persia, and then I'm going really with every step in detail so that I'm providing all the information about the internals. Here it's just a very short overview. Okay, how is Persia delivering this binary? So it's a peer-to-peer network. So if you have now this, for example, Maven dependency inside the Persia network, you are asking here, okay, with a Maven coordinate, this Persia node, then it will be selected where this binary is, and then you can fetch it from several points. So if you have bigger binaries, you have all the advantage of a peer-to-peer network that it could be delivered partially from different nodes to use the bandwidth as much as possible. On the other side, we have gateways to Docker Hub and Maven Central, for example. These are authorized nodes. So if something is not inside the Persia network, it will be fetched from this authorized nodes and then stored inside the peer-to-peer network as well. So if these nodes are going down once, or maybe for a few minutes or whatever, you can always ask the Persia network and it will be still there. On the other side, just have a look at this project website. It's a young project, and yeah, I can say try it out. Okay, we saw that we have different parts, and that one is done by the organizational or operational part, and the other thing is source code and binaries. And I want to highlight 4 main areas of cyber defense or cyber security or the DevSecOps, whatever you want to say to it or where you want to place it. And it's first of all the SAST, the static application security testing. It is a testing mechanism where you are testing each component until it's not running. So it's just from the first line of code, you can say this dependency, and then you're scanning. If something is running already, you have this dynamic application security testing. This means the application is running and you're looking from outside on this, and you have more this hacker approach. And the combination of both is a IaaS, the interactive application security testing. This means you're ramping up the environment, you have from outside the attack, and you're looking inside and modifying the attack vector and all this stuff. And then the last part is runtime application security protection. And the name mentioned already, it is just for production. It means inside your production environment, you're analyzing what's going on and try to identify it is an ongoing attack now. So, okay, the last one I just cut out at this part because it's just for production. If you're focusing on IaaS, it means you need someone who's highly skilled. So this is mostly something that you're doing later if you have experience with the security stuff already. The dust part is quite late inside the production line because you need something that's running already, and you can't really scan 100% of the components because you're just looking from outside. So you should focus definitely on SAST, the static application security part, because with the first line of code you can start scanning all the included components and identifying if there are malicious packages or vulnerabilities. So we saw that we have left over source code in binaries if you want to start with SAST, and I highly recommend to focus first only on the binaries, because if you're comparing how much code you write and how many dependencies you're adding and how many lines of code this is, then for the most projects, the by far biggest part are dependencies. So focus there and scan there for vulnerabilities, malicious code packages. It's the low-hanging fruit if you start with cyber defense or cyber security topics or inside the DevSecOps part. So next question is, what's the best source for vulnerability information? And here I can say, whatever single database you're using, make sure that you are building a superset out of different databases, because single databases are mostly having a lack of vulnerabilities because the market is so huge and you never know to what provider this information is sold. So this is exactly what we at JFrog has done or doing already. So we are aggregating different vulnerability database, commercial one, free one, and we have a dedicated research team on top of this vulnerability database that is enriching this data with mitigation and remediation information, and we are adding the knowledge about our own 0 days as well. So whatever you're choosing, make sure that you have a superset as we have done it in JFrog. Let's talk about malicious packages, and we have different aspects I want to highlight here. And the first one is the infection methods. So what is an infection method? So the way how this malicious code is provided, or it's provided a way so that you're consuming it. I will start now with type squatting. So what means type squatting? Type squatting means that you have common packages, very well-known packages, and they have a name, and you're grabbing this code and then you are changing the name of this dependency based on common typos. And then if you have a common typo, you're just providing this package in a regular official repository, and then with this typo he's just referencing a corrupted package, and inside this package you can do whatever you want. So the next thing is masquerading. So masquerading is focusing on imitating the whole environment around a dependency. So you think you're duplicating the code, the metadata, you're adding small pieces of malicious codes here inside this one, and you're building Trojan packages. So you're building something that looks exactly the same, that maybe has a same name but provided at different places, and then something is inside so that you're infected. That's it. So the only difference from the original package is maybe one line with an obfuscated code that is doing something, calling something, sending something, and so on. The next thing is a Trojan package. A Trojan package is more or less like the historical view. You have a package that's doing something, a PDF library, and it can print and all this stuff. So everything what you need. But inside this, you have additional functionality that's obfuscated, hidden somewhere, and it's just activated during the time you're using this really well working library. So sometimes these Trojan packages, they are good libraries, so they're giving you a good value, but an additional value as well. Another way is dependency confusion. Dependency confusion means that you if you have internal packages and external packages, for example, so inside your company, and I know, for example, because I know someone who's working there or this information is bleeding out, I know what is the name of an internal dependency. Then what I can do is I can create a dependency exactly with the same name and a higher version number or a very high version number, and putting this one in official repositories. So I'm really using exactly the same definition, but my CI environment is looking first maybe at Maven Central and grabbing there this wrong dependency with the same name, maybe same functionality, slightly different version number, so that automatic version increases will grab this one from outside, and then you have this dependency confusion in a way that you see it's my dependency, but it's grabbed from outside. Another infection method is hijacking. Hijacking means that you have access to the infrastructure of this project. You are taking over the ownership in some way. It could be in an aggressive way that you're really hacking the page, having this, or if there's a non-maintained project and you see it's used, then you're just taking this free domain and building again something around it, or you're taking the open source project that nobody is maintaining anymore and doing this one. So hijacking is, it's more or less you are the maintainer of the project, but with a different intention. So these are the common infection methods. And now the question is, what are common payloads? Another thing is, what are common payloads? Common payloads is more or less what they're doing. So what is this code that is in these malicious packages? And then one of the bigger things is sensitive data stealer. So it means they want to have credit card numbers, they want to have user tokens, environment variables, passwords, usernames, whatever. So they want to steal this data and sending them somewhere. So you have this, okay, look, if you have this environment variable, check this name, and with the next request, send an additional request to the attacker server. So that is one thing. The other thing is that you have something like a connect back shell. It's like a remote shell. So there is malicious code that's waiting and connecting back to the attacker server, so that he knows, okay, this malicious code is there, I can connect, then I'm sending commands, it will be executed on the other side, and the result will be sent back. So this is just, whatever you can do at this system to do this one. And another thing that is very popular these days is that you have download and execute. So you have a malicious code that is connecting to a remote server, downloading a binary and starting executing them. And this is quite often used for example, for crypto mining. So just to mine cryptocurrency with other people, energy and money, and sending this one back. So these are the most common payloads that you have in malicious codes. But how to hide this malicious code, and then we are talking about obfuscating techniques. Now, talking about obfuscating techniques. Obfuscating techniques can be just by public available obfuscator or custom-made obfuscator, but mostly you can really search for obfuscators and then you're using it. So what they are doing is more or less they're renaming variables, they're encoding commands in different encoding and all this stuff, so that you are not able to read it immediately. So you have to re-encode it to see what's going on. So this is one thing. But A little bit more interesting is a control flow flattening. The control flow is more or less, you have this control, so it's running A, B, C, D, E, F, G, and then in the middle you're breaking some if then else stuff in, and then depending on the amount of calls or variable or whatever, different code will be executed. And this is so implemented in the code that's not obvious, or that you're not really immediately seeing it. But if you're analyzing the whole control flow, you will see that there is something that is around this main logic. Okay, the next is homoglyph characters. Homoglyph characters is something like you have this different Unicode character that are looking like plain ASCII Latin characters, but they will be different if you're comparing strings and all this stuff. So with this you can make sure that some comparisons always succeed or always fail. So for you it looks like a regular ASCII sign, but it isn't different Unicode sign. And with this you can do a little bit more, and this is this bidirectional control characters, and this is a cool thing. So we are reading left to right, right to left, whatever, and we can say it to the machine as well. And we can use this control characters inside my source code, so that a human is reading maybe from left to right and seeing, okay, this is in source code, here's a command, it's sort, it's end, and so on. And the compiler will see it completely different. He will come to this character, switching from left to right to left, reading and interpreting this stuff, and it's completely different. And this is something that is quite cool in terms of getting this understanding for this, but it's not so easy to detect. So we heard so much about vulnerabilities, malicious packages, masquerading techniques and all this stuff, but the first question is, inside the software development chain, where is the right place to put security in? And the answer is quite easy: everywhere. So every single step should be involved or should be hardened with a security approach. So security is like quality. It is really part of every dedicated step. On the other side, what makes so unique this combination of Artifactory and X-ray, so this dependency management and vulnerability scanning. Have in mind that all dependencies of all tech layers, they have some metadata around. So like, is there a dynamically linked dependency? Is there a compile scope? Is in test scope? Is this in a version range? Is this with a dedicated? Is it statically linked, dynamically linked, and so on and so on. So all this information is available inside these different dependency managers. And if you are grabbing all dependencies of this Artifactory and you have the whole metadata and the knowledge of this, then you can use this metadata to analyze, for example, remediation mitigation information. You can use this for defining the whole attack vector over different technology borders or inside the whole tech stack. So having this information of all dependency managers of all tech layers and the possibility to scan these binaries is a huge plus compared to I'm just scanning one technology or I'm just scanning one binary, because mostly this information is not part of the binary and then you can't use this information. So dependency management and scanning for vulnerabilities is a very good combination. The next question is shifting left to the CI environment enough? Well, shifting left to the CI is good because this is a fully automated gate where passing through. It's the place where you can implement this security border that it must pass before it's going to the next steps. But shifting left to the CI is not enough, because if it's reached CI, then you spend already so much time, and maybe you can do it a little bit earlier. So the early thing, or a little bit earlier than CI environment, is the IDE as well as the command line interface. So we have both of them. We have the command line interface where you can work straight on the command line, you can script it, you can use it to see what vulnerabilities are there. And we have this IDE plugin. So if you're typing the first line of dependency, then you see immediately if there are vulnerabilities in the dependency tree or if there are some compliance issues. why this makes sense. First of all, if you're spending time on creating something, pushing it to CI, getting back that's not possible, and you have to rewrite it, then you're getting bored, and the quality of the second solution is maybe not so good because you are under time pressure now. You wasted a lot of time already, and you are bored because you're doing things twice. So it makes sense to have this information as early as possible available so that you are focusing on the core things once and doing this right without being bored or wasting time. Why you should use the CLI command and how to use it. So first of all, you should use the CLI command because with this you can work without any other tool. If you're cloning a repository like Maven project, then you can just go in on a terminal shell, on a command line, you can go inside this project and call the audit command JFrog audit -nvm. So with audit -nvm, the command line interface, now there is a project, a Maven project. It will extract the whole dependency tree from the POM XML and give you all the vulnerabilities and compliance issues that are defined here. So you can configure it with watches and all this stuff, but plain is just audit it and get all information that are available. So with this, you're not wasting time, so you can check it without starting any workflows or just opening an IDE and all this stuff. On the other side, you can script it so that all other tools, existing infrastructure on your side, is able to use these capabilities as well. On the other side, you can do a little bit more in terms of analyzing, for example, a Docker image. It's called on-demand scanning. On-demand scanning means that you creating a Docker image on your machine, you edit stuff, you grab different things, and you want to know if this Docker image is good enough. So in terms of compliance issues or if you have any vulnerabilities you should get rid of. So you can extract this Docker image so that you have a tar image on your disk, and then you can use the JFrog CLI command to analyze this Docker image, or if you have Docker Desktop, you can use the Docker Desktop plugin to analyze this Docker image. You have immediately the information about what's inside in terms of vulnerabilities and compliance issues, and you can send this information to Artifactory, and then it's under on-demand scanning available, so it's documented, and if you're changing the Docker image, then you see the difference between different scans. So you can work together with your colleagues, you have it documented without pushing anything of this Docker image to this Artifactory, so nothing is bleeding in if you're composing stuff on your side and without using the CLI resources and waiting there. So using CLI makes sense for integration, makes sense to be in fast, and makes sense to analyze what's going on and give you the flexibility to work straight on your challenge, what you have in this environment where you are. A little bit earlier I talked about the SBOM. So what's an SBOM? SBOM is a software bills of materials, means a full list of all dependencies that are used to create this binary. This is quite popular these days because the executive order of cybersecurity from the US President, Mr. Biden, explicitly says that everything that is used, owned, run, whatever by the US government must fulfill this SBOM, the software bills of materials. So you have to provide the full list of all dependencies of all tech layers. We know this since a longer time. We called it these days earlier build info, and build info is a superset of SBOM. So you can add here during the time you're creating a binary not only the whole dependency list, but it is added all meta information you want to add, like environment variables, date, time, machine, agent name, whatever. So everything what's necessary and what you want to push there can be stored there, and it's immutable. On the other side, for this you have this tab about X-ray, and inside X-ray you have the actual knowledge of vulnerabilities. So it means if you're passing a build today and it's green, because today we don't have the knowledge about vulnerabilities that are inside, and passing this to production, maybe tomorrow with an update of the vulnerability database, we know, oh, we found a new vulnerability, then we know that for this binary we have no vulnerability in. So we have this information without scanning production, and on the other side it's a good, good thing to on the daily in the morning just to scan for the importance binary to check that I created yesterday, so if there's a new vulnerability entry there, for example. So with this, you can maintain production without scanning it. And on the other side, you can, at this X-ray tab, going to this action thing, clicking there, and then you can create an SBOM and extract the SBOM in different variations. So it depends what standard you have to fulfill. And then you have everything to be compliant with this executive order of cybersecurity. So it means we have now the possibility to create this SBOM. We have the possibility to see vulnerabilities from in the past created binaries without scanning everything, and we can use this to actively maintain stuff that is running in production. By the way, you will find there a lot of CVSS values in certain places, and if you're clicking on CVSS values, you see all the basic metrics. I have not enough time to explain now all these different metrics values, but I have a dedicated YouTube talk that is going through all the CVSS metrics, and you will see that you have the possibility to scale the CVSS metric to your environment, and for this you need environmental metrics. How to use this and how to deal with the CVS calculator is shown in one of my videos there, and it's good advice to see and play around with the CVSS values, because it will give you some advice which one is more important for your environment, and you can adjust the order in which you want to fight against vulnerabilities. Okay, we had a lot of stuff now. So we talked about supply chain security, about software supply chain security, about these two Linux Foundation projects. We saw what is the difference between vulnerabilities and malicious packages, different techniques to obfuscate, and so on and so on. I showed you how to extract this SBOM and what you can do in command line, and why shift left through the CI is not enough. You should shift left through the IDE or command line interface. Altogether is a one package, but there are a lot of more detailed videos to single topics on my YouTube channel, so just check it out. And if you are interested, try it. We have a free tier, so there you can register and try all this stuff by yourself, or attend one of my webinars or workshops where we have hands-on practice on exactly these topics. The other side, my day is more or less done. I found this lake. I will make my camp here for tonight. We'll enjoy it. And whatever time you are seeing this, I hope you will have a good rest of your day. And, well, stay safe and see you